Hi, this is Brian Kim. I want to share with you case number 159 in the Best Way to Do Cataract Surgery series. This is a patient who has somewhat of a dense cataract as well as a smallish pupil. You're going to see careful lens disassembly, doing double chop and cross chop, and using mechanical fracturing forces to crush the lens pieces into smaller and smaller pieces. By doing it this way, you're able to reduce potential trauma to the cornea and also have clearer corneas postoperatively, faster visual recovery. And then at the end, you'll be able to see I'm going to place the Hydrus Microstent as well. You can see beautiful blanching at the very end of the case once I place this Hydrus, and it goes really quite textbook and quite easily in this particular case. So I use a corneal marker, which will help me to center and size the rhexis. And then I'm turning the eye towards the left with the cotton tip, and then making my paracentesis incision first on the right side and then the left side. And it's so important to make sure you have a nice flat approach. If you don't, you're going to have a short incision and therefore more prone to leakage. And so when you have this longish tunnel when you're doing your paracentesis, this really ensures that these paracentesis incisions will not leak. So this is intracameral lidocaine and then some intracameral epinephrine and then some dispersive viscoelastic to coat the corneal endothelium and flatten the anterior capsule, but it also did some viscodilation as well. And this is a triplanar corneal incision. I make a vertical groove, place the blade into the deep part of the groove, tunnel through the cornea, and then I enter. And I remember to make my Hydrus incision before I get started. Early on, I made my incision right when I was going to do the case, and there was some conj bleeding and it really messed up my view. And so I've learned to place that Hydrus incision at the very beginning. And so that's another tip for you all. If you want to make your Hydrus incision early on, since you know you're going to do it, that helps reduce any potential risk of bleeding or blood getting into the interface when you place your gonio lens. So this is the sharp tip Haldane-Perkar forceps. I puncture the center and then pull down. And then I grab the edge of the tear going around circumferentially, and I'm able to follow the corneal mark that I made in order to get a well-centered and sized rhexis. You can see because of these forceps, these low-profile forceps, very little viscoelastic egress and very well-controlled capsulorhexis. This is the capsulorhexis hydrodissection technique. I place a cannula under the rhexis edge contra-incisionally, point the tip down, get a nice wave, gently decompress on the left side, sweeping along the left side and pushing some fluid, hooking the peripheral lens on the right side, and the lens begins to spin. Again, you can see this is a pretty dense lens just by the appearance of it and a smallish pupil here. Lifting the incision with the chopper, going in with irrigation off to minimize Descemet's trauma. Removing the surface epinuclear material. And here we go in half speed. I'm making sure I go underneath the rhexis edge, pronating my hand. And once I get to the capsular fornix, I tilt the chopper vertically, making sure I'm at the equatorial plane. I rotate and tilt the phacoetip vertically, subincisionally. I make sure I hook it and stab the lens. Now I have opposing forces. I'm able to bring the instruments together and crushing the lens in half between the instruments. You can see I'm spreading and spreading. I get nice separation of the lens here. Again, you're dealing with this fairly dense lens with the borderline pupil. You want to make sure there's good separation. I placed the chopper underneath the right heminucleus under the rhexis edge, pronating my hand again. And once I get into the equator, I turn the chopper vertically, pull it centrally towards the phacoetip. The phacoetip is deep between the lens pieces. I'm able to crush the lens against the phacoetip with the chopper, and that is the cross chop maneuver. This is in normal speed, performing the same maneuver with the double chop, bringing the instruments together, and I'm able to sandwich the lens with two opposing forces on either side, contra-incisionally with the chopper and sub-incisionally with the phacoetip. I'm able to hook the peripheral lens under the right heminucleus and then perform the cross chop maneuver. Again, very efficient lens disassembly with this maneuver, and the key is being able to hook the peripheral lens with the chopper here. I place the chopper around that first quadrant, hooking the peripheral lens, crushing it between the instruments, and then using some vacuum to lift that fragment up, crushing the lens between the instruments one more time. And once the lens pieces are small enough, I'm using high vacuum as well as pulses of ultrasonic energy. You keep doing that same maneuver over and over again. Place the chopper underneath the second quadrant, hooking the peripheral lens, pulling it centrally toward the phaco tip, and then crushing and bisecting that second quadrant into two pieces. You can see there's good separation. You can see I'm using the chopper, and this does require really good control and bimanual dexterity with this technique. But again, that shouldn't be too difficult. It's just a matter of practice and prioritizing and really trying to get good bimanual dexterity using, because we're not just using one hand, we're also using both feet. We're listening with our ears and what we're doing. This is really a full sensory surgery when we do cataract surgery. And so you can see I'm able to disassemble that second quadrant very easily and confidently, again, because I'm able to hook the peripheral lens with the chopper. Those are the last remaining pieces of the second quadrant. I carefully rotate the second heminucleus in front of me, placing the chopper underneath the rhexis edge, hooking the peripheral lens, pulling it centrally towards, it didn't actually get all the way across, and now I can feel I got it. And it's like hooking a fish. When you feel you got it, you know you got it. You got around the peripheral lens. I pull it centrally towards the phaco tip. You can feel the density of the lens as you're pulling the chopper against the phaco tip. And then as you complete that pulling force towards the phaco tip, it cuts the lens completely in half. It's really quite gratifying. And again, for those people who don't know the surgery and they're skeptical and they don't quite understand the surgery, my first statement to you is, without doing the procedure and knowing how to do it, unfortunately, you really don't have a great perspective on the strengths and weaknesses of the technique. And so my suggestion is learn how to perform the technique, and then you might be able to have better input on how the surgery is. And again, that tactile feeling of crushing the lens is something that really isn't discussed, or really something you encounter when you're doing the typical standard chop techniques with horizontal chop or vertical chop. It's just really a different type of technique. You saw that I pushed some more viscoelastic in to coat the corneal endothelium because this is somewhat of a dense lens. And then I'm able to carefully position the chopper around that lens piece, crushing the lens piece into smaller pieces again. Because I filled the eye with some viscoelastic, I have excellent control. I'm able to, again, position the instruments around the lens pieces and then just crushing it over and over and over again. And that, again, tactile feel, knowing how to position the lens, this tells you you can crush and disassemble lens pieces from any which way. And so remember, in traditional chop techniques, you have to chop within and along the axis and plane of your main incision. And that's whether you're sculpting, you have to be along the axis of your main incision. Yeah, when you're doing vertical chop, horizontal chop, it's really essentially the same thing. But when you're doing this maneuver and you're doing mechanical fracturing forces, in particular cross chop, you can chop along any plane. And so that's really kind of a subtle point, but it's so, so important to be able to articulate that. And once you understand, you're like, oh, wow, that's the strength of the techniques. I'm able to perform cross chop and disassemble these pieces from any direction. So essentially, I'm able to chop along the main axis of the main incision, but also any plane on the right side of me. And that's because the chopper has easy access to that right side of the phaco tip. Because the chopper is coming from the left side, again, it's at 90 degrees, and I'm able to place the chopper around the peripheral lens, and I basically use that phaco tip as kind of like a cutting board or a chopping block. And so I'm able to push that chopper and pull that chopper toward the center, towards that chopping block, the phaco-tip, and I'm able to crush the lens against the chopping block. And so that's the beauty of this technique. Again, that chopping block principle, I'm able to very confidently disassemble any lens by using this technique. I never feel like I have trouble or I'm stuck in any way, and I'm able to mash the lens pieces into smaller pieces. And as a result of that, I'm able to utilize less ultrasonic energy and therefore gentler on the cornea, and as a result, faster visual recovery with my cataract surgeries. And so this is the last piece. I'm using, again, crushing forces to just sandwich and crush the lens piece into smaller and smaller pieces, using high vacuum to do this, and then pulses of ultrasonic energy as well. I'm mindful of the posterior capsule being exposed, and whenever I'm using the high vacuum and ultrasonic energy, I have the chopper to protect the posterior capsule. So I take the chopper out, there's a lens piece that's in there, I was able to push it out, and then I push BSS in, take the phaco tip out, and I go in with the I&E handpiece. I start sub-incisionally removing the cortical material, and I like to sweep side to side to get large sheets of the cortex out. Again, with these machines, the pressure, the vacuum pressure is just so strong with these machines. It's really easy to just peel stuff off. But as a result, you have to be very mindful that you don't grab the capsular bag or also, the zonules. And because this is a smallish pupil, I don't want to grab indiscriminately, so I switch to polish mode and I'm polishing underneath the rhexis edge. Again, since I don't have really good peripheral view, once I grab a little lens piece, I switch to Cortex mode, eat that piece up, and switch back to polish mode, polishing underneath the rhexis edge of lens epithelial cells. And then I'm going to go ahead and polish into the subincisional space with the BSS cannula. Looks pretty clean there. And then I'm going to push some cohesive viscoelastic to fill the capsular bag. This is somewhat of a smallish pupil, so rather than sweeping, I'm going to go ahead and place the lens, the single piece acrylic lens, into the capsular bag. I'm able to turn the lens away from me. I can see the edge of the rhexis there. And so I'm making sure that the lens is definitely going underneath the rhexis edge into the capsular bag, at least the leading edge. Quickly transition to the cannula, making sure that the lens is completely in the bag and disengaging the haptics off the optic. And I'm doing it this way because I'm preparing for the Hydrus. And so now we're going to do the Hydrus. You can see I'm rotating the microscope so that it's really pointed away from me. And you want to be able to do it that way so you have a better angle when you're doing the MIGS procedure. So I'm tilting the microscope away from me, and I'm having to adjust my oculars. I'm also turning the eye away from me. So you can see now the eye is turned away, refocusing myself. You always want to zero out too when you're doing this. This is another tip. All your X, Y, Z, you want to zero out and make sure you go back to the center. Because once you get started, you don't want to be stuck because you're at the edge of your focus. Injecting some more cohesive viscoelastic to fill the chamber and then placing it on the cornea. And this is a Hydrus. I'm just positioning it the way I want to, and I'm rolling the Hydrus out just to see that I have it there. I place it in the incision first, and then I place the gonio lens. I have really nice en-face view. Again, that means I have equal amount of cornea and iris visible, which means that this view is essentially perpendicular to the stent. So again, I'm angling slightly up into the anterior TM. I'm stabbing into TM. I'm angling and then I'm advancing the Hydrus. Once I have the Hydrus coming forward, you can see I'm flattening out my approach. So instead of keeping that angle, I'm flattening it out so it's more in line with the curvature of the cornea and TM. I advance the Hydrus completely, and then I pull back so I can only expose the shovel tip, and then I'm placing that shovel tip at that distal notch, and I'm trying to slide the rest of the Hydrus into position. Right there. So you get good position right there. And now you can see I have excellent view of the hydrus. You can see the windows. You can see the glistening of the hydrus. So it's in good position. You can see heme coming out, which also tells you it's in good position. You can see the entire length of the hydrus is well positioned after placement. So I'm repositioning my microscope and the head, and I go in with the INA handpiece, going underneath the optic, tilting it and rotating it 90 degrees, removing all the viscoelastic from within the bag. And then I'm going to polish underneath the rhexis edge here. And then I'll remove the viscoelastic from the anterior chamber, and then I'll hydrate my incision. So you can see here, there's about 120 degrees of blanching, really, really nice blanching here. I've really been happy with the hydrus. It's really a no fuss technique. And again, as long as you execute it, you get really good results. You're just not that much guessing or second guessing because it's going along the entire length of that angle right there, distally. And so you can see, again, double chop, cross chop on this very dense lens, borderline pupil. I don't have to worry about visibility. I don't have to put iris hooks or use a ring or anything like that because I'm confident of my chopper position. I'm able to place the chopper under the rhexis edge, rotate it vertically. When I get into the capsular fornix, I'm able to effectively and confidently hook the peripheral lens, and then I'm stabbing the lens on my side, the proximal side, with the phaco tip. And by doing it that way, I'm able to immobilize the lens, fracture the lens completely in half. And with the hydrus, you saw the excellent blanching as well at the end of the case. And so this patient had really good pressure reduction after surgery and fast visual recovery after the cataract surgery. So I hope this was helpful to you, and I thank you for your attention.